universe. You may wonder how a small stone sinks readily in the water, while a big ship made of steel floats comfortably in the seawater. The following slides under the name floating body and Archimedes principle may perhaps satisfy your inquisitiveness. Let's start with buoyancy. When a body is totally or partially immersed in a liquid, it displaces some liquid. The displaced liquid exerts a net upward thrust on the body. This tendency of the displaced liquid to exert a net upward thrust is called buoyancy. The net upward thrust that the liquid exerts on the body is known as buoyant force. The buoyant force makes the corresponding body apparently lighter than it is actually. It can be proved that the buoyant force exerted on a body by the liquid in which it is immersed fully or partly is equal to the weight of the liquid displaced by the body. In other words, the buoyant force is equal to the apparent loss of the weight of the corresponding body. Let's now go through Archimedes' principle. When a body is immersed partly or wholly in a fluid at rest, it appears to lose a part of its weight, and the loss of weight is equal to the weight of the fluid displaced by the body. Archimedes' principle is vastly utilized in different areas. With the help of Archimedes' principle, we can determine the weights of the constituent elements in a piece of alloy. Suppose an alloy is made of two elements A and B. Rho A and rho B are the densities of element A and element B respectively. The piece of alloy has weight W. Rho W is the density of pure water. The piece of alloy is entirely immersed in the water, and the apparent loss of the weight of the piece of alloy is found to be delta W. With the help of Archimedes' principle, we have the expressions for the weights of element A and element B in the piece of alloy as follows. We can check whether a body is hollow or solid with the help of Archimedes' principle. Let the body to be tested have a weight W. Let rho naught be the density of the material of the body. Rho W is the density of pure water. Delta W is the apparent loss of the weight of the body when it is fully immersed in the pure water. Then, the following are the conditions to determine whether the body is solid or hollow. Archimedes' principle can help us determine the density of the material of a solid body. Let W be the weight of a solid body. Rho is the density of a certain liquid. Delta W is the apparent loss of the weight of the body when it is fully immersed in the liquid. Then, the following is the expression for the density of the material of the body. Let's now learn the conditions for flotation and immersion of a solid body. If the density of the material of a solid body is greater than the density of a liquid, the solid body will sink in the liquid. If the density of the material of a solid body is equal to the density of a liquid, the solid body neither sinks nor floats up, and remains at rest in the liquid. If the density of the material of a solid body is less than the density of a liquid, the solid body floats when it is placed in the liquid. When a solid body floats in a liquid, the fraction of its entire volume that remains under the surface of the liquid is equal to the ratio of the density of the material of the solid body to the density of the liquid. Let's now know the conditions for the equilibrium of a floating body. Two conditions have to be met for a body to float in a liquid. Condition 1. The floating body must displace its own weight of the liquid in which it floats. Condition 2. The center of gravity of the floating body and the center of buoyancy must lie in the same vertical line. It is to be noted that the center of buoyancy is the center of gravity of the liquid displaced by the floating body. Let's go a little deeper into condition 2. For the floating body in the diagram, AB is the central line, G is the center of gravity of the floating body, H is the center of buoyancy, that is the center of gravity of the liquid displaced by the floating body. In this case, the center of gravity and the center of buoyancy are in the same vertical line. Hence, the body floats at rest in the liquid. In another case, as shown in the diagram, the center of gravity and the center of buoyancy are not in the same vertical line. Hence, the body cannot float at rest in the liquid. Now, let's gain some basic knowledge about the stability of a floating body. There are three states of equilibrium for a floating body. Number 1. Neutral equilibrium. In neutral equilibrium, a body floating in a liquid remains at rest in its new position when it is tilted a bit. A football floating in the water is an instance of neutral equilibrium. Number 2. Stable equilibrium. In stable equilibrium, a body floating in a liquid regains its original position and remains there at rest after it is tilted a bit. Number 3. Unstable equilibrium. In unstable equilibrium, a body floating in a liquid cannot regain its original position and rather overturns when it is tilted a bit. Metacenter plays a vital role in the stability of a floating body. What is metacenter? When a floating body is tilted a bit, the point at which the line of action of the buoyant force intercepts the central line is the metacenter. In the diagram, capital B is the buoyant force and its line of action cuts the central line at M. Thus, in this case, M is the metacenter. The metacenter may be located above the center of gravity or even below the center of gravity. If the metacenter is located above the center of gravity, it means that the floating body has been tilted from a stable equilibrium and will regain its original position. If the metacenter is located below the center of gravity, it means that the floating body has been tilted from an unstable equilibrium and will eventually overturn.